When we consider negative numbers, we're first going to consider what happens when the numerator of our rational exponent is an even number. So that means we're taking an odd root followed by an even power. We're taking an even power then. In order to eliminate our even power, we need to use the even root property. So if we have x to the power p over q equals some number, we can take the q over p power on both sides. But notice here we're taking secretly an even root. We're taking the pth root as part of taking that rational power. And we can either have the positive pth root or the negative pth root. And so x to the p over q equals c has a plus solution and a minus solution if c is the kind of number of which we can take an even root, so positive or 0. If c is negative, then this equation has no solution because x to the p over q has range 0 to infinity. So if we have a negative number as output, that can't happen. Let's see how we apply this in practice. In this first example, we have x to the 2/3. Notice the numerator of this fraction is even. And this x to the 2/3 expression is not isolated. So the first thing I'm going to do is isolate x to the 2/3. We'll subtract 3 on both sides, and we'll get 2 times x to the 2/3 equals 18. We'll divide both sides by 2, and now we have x to the 2/3 equals 9. We split this in half. There are two possible solution paths here. We can have either x is positive 9 to the 3/2, or x is negative 9 to the 3/2. Right, so we've taken the reciprocal of the exponent, and because hidden in there we have an even root, we can either have the positive or the negative root. And now 9 to the 3/2 we can work out on a calculator. X is 27, or x is negative 27. To check that this actually works, if I take 2 times 27 to the 3/2 plus 3, that's 2 times 9 plus 3 really is 21. If I take 2 times negative 27 to the 3/2 plus 3, well, negative 27 to the 3/2 also gives me 9. So 2 times 9 plus 3 still gives me 21. In this next example, we have 3x plus 1 all to the 4/5 equals 16. So my 4/5 power is already isolated. So eliminating that is going to be my first step. And it gives me two solution paths. Either 3x plus 1 is positive 16 to the 5/4, or 3x plus 1 is negative 16 to the 5/4. Evaluating 16 to the 5/4, I get 32. So 3x plus 1 is 32, or 3x plus 1 is negative 32. and then we just finish solving each one. 3x is 31, x is 31 thirds, or 3x is negative 33, x is negative 11. Plugging in to check, we'll have 3 times 31 thirds plus 1 to the 4/5. That's 32 to the 4/5, which works out to 16. 3 times negative 11 plus 1 to the 4/5. That's negative 32 to the 4/5, which also works out to 16. So the two solutions that we get actually do both work in our equation when we go back and plug them in. We have to remember that if we have an even numerator, hidden in our solution steps is an even root, so we need to use the even root property and introduce a plus or minus.